Okay, in lesson 62, we're going to be talking about square roots. Now we already know, we think we know what a square root is, but now we're going to talk about a little more in detail the exact definition of square root and just a few things about it that we haven't really talked about before. So first of all, remember that the definition of square root is this. The square root of a number x is the number you multiply by itself to get x. So the square root of 4, all right, you would say that's 2. The reason the square root of 4 is 2 is because 2 times 2 is 4. So the square root of 9 is 3 because 3 times 3 is 9. The square root of 16 is 4 because 4 times 4 is 16. So the definition of square root is the number you multiply by itself to get x, if you're talking about the square root of x. All right, so that's going to be something that you really have to nail down now. You can't just think about it in terms of square roots that have a whole number answer. Some square roots, in fact, most square roots are not whole numbers. They're irrational numbers. But they're still the number that when you multiply by itself, you get whatever the number is that you're taking the square root of. All right, so but first of all, let's just talk about the fact that every positive integer actually has 2 square roots. We usually only talk about the positive square root because we usually use the radical symbol, and the radical symbol expresses the positive square root of a number. But every number, every positive number, has exactly 2 square roots, one positive and one negative. For example, 16 has 2 square roots, 4 and negative 4, because by the definition, the square root of 16 is the number you multiply by itself to get 16. So 4 is a square root of 16 because 4 times 4 is 16. But negative 4 is also a square root of 16 because negative 4 times negative 4 is also 16. So 4 and negative 4 are both square roots of 16, but be very careful because whenever you see the radical sign, you only are meaning the positive square root. So if you want to talk about the negative square root, you don't use that radical sign. You'd have to put a minus sign in front of the radical. So whenever you see that radical sign, you only mean the positive square root. But the fact of the matter is that every positive number has 2 square roots. One positive and one negative. All right, so again, I'm trying to stress this definition. If x is greater than 0, that is, x is a positive number, then square root of x is the, and using the radical sign now, is the unique positive real number such that if you take that number and multiply it by itself, so square root of x squared, you're multiplying it by itself, square root of x times square root of x will equal x. That's what square root means. It's the number you multiply by itself to get x. So here's where that definition is really going to come into play, is looking at these situations here. All right, the square root of 2, for example, is the number that you multiply by itself to get 2. So the square root of 2 times the square root of 2 is 2, because that's what square root means. The number you multiply by itself to get 2. The square root of 2 is the number you multiply by itself to get 2. The square root of a is the number you multiply by itself to get a. So the square root of a times the square root of a is a. The square root of 2.42 times the square root of 2.42 is 2.42. That's what square root means. It's the number you multiply by itself to get whatever that number is under the radical. The square root of x minus 1 times the square root of x minus 1 is x minus 1. Every time you multiply a square root by itself, you get that number that's under the radical. So the square root of 4 times the square root of 4 is 4. The square root of a billion times the square root of a billion is a billion. All right, I can't stress that enough. So the square root of a counting number is either a counting number or it's irrational. This is what I was talking about before. Either the square root of a whole number like the square root of 4, okay, it's going to be a whole number like 2. It's going to be a counting number. So square root of 4 is 2. That's a rational number. It's a counting number. That's going to be true. Or the only other possibility is if you take the square root of a counting number like 3, square root of 3, that's not a whole number because there is no whole number, no counting number that you can multiply by itself to get 3. Therefore, it will be irrational. So when you take the square root of a counting number like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on, you're either going to get a whole number, like when you take the square root of 4, you get 2, and you take the square root of 9, you get 3, you take the square root of 16, you get 4. You're either going to get a whole number or you're going to get an irrational number. Like the square root of 2 is irrational. Square root of 7 is irrational. All right, and all irrational numbers, we talked about that set, are non-repeating, non-terminating decimals. They're decimals that go on and on. The decimal part continues on and on. It doesn't repeat in a pattern. It doesn't end. It just keeps going. That is what is an irrational number. So an irrational number cannot be written out exactly. We can only write an approximation. All right, so if you want to, well, first of all, let me just say in your notes, I think this says rational. It should be irrational. An irrational number can only be written out, cannot be written out exactly. You can only write it as an approximation to a certain number of decimal places. All right, so use a calculator to give an approximation for the square root of 18 to 5 decimal places. Okay, so you're going to take your calculator and you are going to punch in the square root of 18. So you hit 18 and then you hit the square root symbol. And you get 4.242640677 or 687. All right, so you're supposed to be rounding this to 5 decimal places. That means 5 digits to the right of the decimal point. So 4.24264, that would give you 5 digits to the right of the decimal place. That's what it means when it says round it to 5 decimal places. And you wouldn't round that 4 up to a 5 because this is a 0. So you look at the 6th decimal place, the 6th digit, and if it's less than 5, you keep that 5th digit, whatever it is. All right, so this one says use a calculator to find the 2 square roots of 10 to 6 decimal places. Now you're going to find both square roots of 10, the positive and the negative square root. Your calculator will give you an approximation of the positive square root, and then for the negative square root, you just take that number and put a negative sign in front of it. So the 2 square roots of 10, you would take your calculator and make sure you clear it a couple of times or whatever you need to do, and then you're going to punch in 10 and you're going to hit the square root sign. All right, so that square root of 10, the positive square root, is 3.167 or 3.162277766, and so on. It doesn't have, it doesn't repeat, but it just keeps on going. But your calculator just gives you that many decimal places, but you want to round it to 6 decimal places. So you want 6 digits to the right of the decimal place. So you're going to have 16227, and then it's going to be 8 because the 7th decimal place, the 7th digit is 6, which is greater than 5. So you're going to round that 6th digit up. So you would have 3.162278 for the positive square root of 10. And the negative square root of 10 looks just like it, except it has a negative sign in front. Because if you multiply 3.162278 and so on by itself, you get 10. And if you multiply negative 3.162278 times negative 3.162278 and so on, you will also get 10. So the positive and the negative square root of 10. Those are approximations. Be sure to know the square roots, these perfect square roots of the following counting numbers. 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, and then 16 squared is 256. The reason it's good to know that one is because It has to do with computers. 16-bit is that 256 just comes up a lot, so you need to know that. And then 20 squared is 400. You could know 30 squared, 40 squared, those also. But these are the ones that you should have in your brain that you shouldn't have to punch into a calculator. So if you don't know them, make sure you learn them. All right, so without using a calculator, determine between which two consecutive integers the square root of 10 lies. All right, so you're trying to figure out, and I spelled integer wrong there, I can see. Let me fix that. That is not, have an R there. Okay. All right, so without using a calculator, determine between which two consecutive integers square root of 10 lies. All right, square root of 10 is irrational. So it's not a whole number. And the question is, between which two integers is it? All right, and we just did a problem where we found out the square root of 10, sorry, let's get back to that. Yeah, we found out that the square root of 10 is about 3.162278. So we already know that it is between 3 and 4. But let's see how we would figure that out if we didn't use a calculator. All right, so without using a calculator, determine between which two consecutive integers the square root of 10 lies. All right, so first of all, remember the definition of square root. The square root of 10 is the number that you multiply by itself to get 10. So the square root of 10 times the square root of 10 is 10. That's what square root means. It's the number you multiply by itself, in this case, to get 10. All right, then think. All right, 3 times 3 is 9. So the square root of 9 is 3. 4 times 4 is 16. So square root of 16 is 4. So the square root of 10 has to be between those two things, because square root of 10 times square root of 10 is 10, and 10 is between 9 and 16. So the square root of 10 must be somewhere between 3 and 4. So that is the two integers, the two consecutive integers between which the square root of 10 lies. All right, so that's how you would figure out that the square root of 10 is between 3 and 4. Because you think about it, you know that 3 is the square root of 9, 4 is the square root of 16, so the square root of 10 is between 9 and 16. 10 is between 9 and 16, so the square root of 10 must be between 3 and 4. All right, we can extend the idea of square roots to higher order roots, right? We've got cube roots. So if x is a real number, then the cube root of x is the unique positive or negative number such that the cube root of x cubed is x. So this is the number you would multiply by itself 3 times to get x. Same thing with a fourth root, the definition of a fourth root. If x is a real number, then the fourth root of x is the unique positive or negative number such that the fourth root of x to the fourth power is x. So this can go on 5th roots, 6th roots, and so on. Okay, they all have that same basic definition. It's the number you multiply by itself a certain number of times to get whatever that number is under the radical. All right, so without using a calculator, determine the following. Cube root of 8, that's the number you would multiply by itself 3 times to get 8. And that number is 2. 2 times 2 times 2 will give you 8. So this cube root of 8 is 2, because that's what cube root means. Cube root of 8 times cube root of 8 times cube root of 8 is 8. So cube root of 8 must be 2, because that's what you multiply by itself 3 times to get 8. All right, the fourth root of 81. We know that the fourth root of 81 times the fourth root of 81 times the fourth root of 81 times the fourth root of 81 is 81. So what number can you multiply by itself 4 times to get 81? That number is 3. 3 times 3 times 3 times 3 is 81. So the fourth root of 81 is 3. If you want to find the cube root of negative 27, the cube root of negative 27 times the cube root of negative 27 times the cube root of negative 27 is negative 27. So that number that you multiply by itself 3 times to get negative 27 has to be negative 3. Negative 3 times negative 3 is 9 times negative 3 is negative 27. So when you have a cube root or a fifth root or a seventh root, you can have negative roots. If the root is an odd root, you can also have negative roots. With even roots, you only have positive numbers under the radical. All right, so the cube root of negative 27 is negative 3. All right, a quadratic equation is an equation where the highest power on x is 2. Okay, so something like this, x squared equals 4. That is a quadratic equation. All right, the highest power on x is 2. And that equation has two solutions. Every equation where the highest power on x is 2, it will have two solutions, just like a linear equation has one solution. A quadratic equation will always have two solutions. In this case, the solutions are 2 and negative 2. If you put 2 into that equation for x, 2 squared equals 4, that is a solution. If you put in negative 2 for x, negative 2, if you square it, it's negative 2 times negative 2, which is also 4. So the two solutions to that equation are 2 and negative 2. And when we want to indicate two solutions like that, we use the symbol plus or minus. All right, so when you solve that equation, you would say x equals plus or minus 2. It means plus 2 or minus 2. So it includes both possibilities. All right, if you see that symbol between two numbers, if you have something like 7 plus or minus 2, that means two numbers, 7 plus 2 and 7 minus 2. So it means both 9 and 5. 7 plus or minus means both of those answers. 7 plus 2, which is 9, 7 minus 2, which is 5. So it indicates both of those numbers. Okay, so if you had something like this where you want to evaluate negative 2 squared plus negative 3, the whole thing squared, plus or minus the square root of 4, you would get two possible answers. So you'd have negative 2 squared is negative 4, negative 3 squared, where you have the negative 3 in parentheses means negative 3 times negative 3, which is positive 9. And then you've got the plus or minus the square root of 4, which is plus or minus 2. All right, so the two possible solutions would be negative 4 plus 9 would be 5. And then you've got 5 plus or minus 2. So 5 plus 2 is 7. 5 minus 2 is 3. So those two different answers would go with that expression. It could be 7, it could be 3, depending when you have plus or when you have minus. So you have to include both possibilities.